Okay, so this is a nice question. If I is the intensity of absorbed light and C is the concentration of AB for the photochemical process, AB plus H mu gives AB star, that's the product. The rate of formation of AB star is directly proportional to. And the answer they gave for this question is D, C times I. And why is that? I'm going to explain this. So consider this system that you have some part of the solution on which photons are striking. So photons are entering this solution, and at some given time some photons will be inside the solution. And whenever these photons come in contact with these green blobs, which are basically this AB thing, so whenever they come in contact with the AB molecule, which is represented by the green blob thing, they will do the reaction and they will form this red blob. Okay, but I'm not drawn all the red blobs because they don't matter, they are not involved in the reaction. Right. So the time required for a photon to pass through the solution, so to pass through this L distance, it's going to be T, and in this time n, capital N, new photons enter the solution and capital N of the old photons leave. And it's obvious that n are going to enter and similarly n are going to leave because it's a steady state system, right? So the speed of each photon is the same, right? So you are just making a lot of photons fall on it at the same time with the same speed. So here you can see these old photons, which I have marked with the orange ones. So these are going to leave it completely. Why is that? Because the last layer, it's moving with the speed c. So in time t, it will move distance l. So once it has moved l distance far, now it will be at this position. So at this position, similarly the same thing for this blue line thing. Okay, so it's going to be going L distance as well. So what that means is that all of these old photons, they will leave the solution in the given time t, and n new photons will enter it. So what that means is at any time the solution contains capital N photons inside it. Okay, so now let's write the equation for the intensity. The intensity is nothing but the power upon area, which is the energy upon the area times time. So in this case I have written time as t because that's the only thing which we can deal with. So what's the energy that we have imparted on this solution in time t? That will be the number of photons that entered the solution times the energy of each of them, which is h mu. So this equation can be written like this: capital N upon Na. Na is the Avogadro's number, and that thing times Na h mu upon At, which then can be written as small n upon capital At. So this small n is capital N upon Na. I have just renamed it as small n. Basically the small n thing is the number of moles of the photons inside this solution. So small n upon At into all this stuff, and since t is just L by c, so c is the speed of light. Okay, so it's going to be L by c. So we can write this equation like this, and basically V is A into L, right? So A is this area on which the photons are striking. So N by V, this thing is almost like the concentration of photons, if that makes sense. So first of all, the intensity is proportional to whatever this N by V thing is. So N is the moles of photon in the solution, V is the volume of the solution. So now let's think of the photons inside the solution as one of the reactants in this reaction. So photon plus AB molecule gives products, which is basically AB star. So this reaction can also be thought as a collision. That's what we do for almost all of the reactions in chemical kinetics. We think of them as being collisions, and that's why we can apply the law of mass action, or whatever that thing is called. I think it's called law of masses, I don't know, but what it states is that the rate is proportional to the concentration of the reactants. to the stoichiometric coefficient, but that's some other stuff. Okay, so over here the concentration of this purple reactant, which is the photon, that thing is going to be n upon v, and the concentration of this green reactant is c, that's given to us, right? Yeah, so the concentration of AB, that's going to be c, that's given to us, and the concentration of the photons, we just calculated it to be n by v, which now we know is proportional to the intensity. So we can say that the rate is proportional to intensity times concentration. That's it. And yeah, that's it. See you in the next video.